November 6th. For Stranger Things fans, that date is a pretty big deal. It's the day Will Byers vanished and 11 accidentally tore a hole into the Upside Down. Now, obviously, that's fiction. But what if I told you that some of the greatest scientific minds have theories about parallel worlds that sound, well, strangely familiar? Okay, let's dive right in.
So this quote is straight out of the Dungeons & Dragons handbook the kids use to make sense of everything. It's their origin story for the Upside Down, this dark, twisted echo of their own world. And while it comes from a fantasy game, you'd be shocked at how close some real science gets to this exact idea.
So that's the big question, right? Can we actually find a scientific explanation for a real-world upside down? Could a parallel dimension like that truly exist? Well, the answers get a lot weirder than anything you've seen in the show.
Our journey into this whole thing has to start in a familiar place, with the idea of a world just like ours, but different. A dark reflection hiding just out of sight. It's the core of the show for sure, but it's also the jumping-off point for some seriously deep scientific questions.
So why? Why would brilliant scientists, people like Stephen Hawking, even spend time thinking about something that sounds like it's straight out of a comic book? What's the scientific puzzle that leads them to this wild idea of a multiverse?
The problem is, our universe seems rigged. The fundamental rules of physics, the numbers that basically control everything, are tuned so precisely that they allow for things like stars, planets, and eventually us to exist. For example, because of some very specific quirks in physics, the element carbon is superabundant. If those rules were just a tiny bit different, there'd be no carbon, no building blocks of life, nothing.
This whole mystery is called the fine-tuning problem, and one of the most elegant solutions is, you guessed it, the multiverse. Think of it like walking into a clothing store. If you see one single bright yellow shirt all by itself, it feels weirdly improbable, right? But if you see it hanging on a giant rack with shirts of every color you can possibly imagine, well, suddenly it makes perfect sense that one of them would happen to be yellow. Our universe might just be that one lucky shirt.
Okay, so let's say we're open to the idea that the multiverse is a real possibility. What would it even look like? Well, it turns out there isn't just one theory. Physicists have come up with at least 4 completely different ways we could be just one universe among many. So let's walk through them, from the simple to the seriously mind-bending.
The first one is maybe the easiest to get your head around. It starts with one simple idea. Our universe just goes on forever. It's infinite. Now, if space is infinite, but the number of ways you can arrange particles is finite, well then those arrangements have to repeat eventually. It's just a numbers game.
Imagine you're shuffling a deck of cards. The number of possible combinations is astronomical, but it's not infinite. So if you could just keep shuffling for all of eternity, you are absolutely guaranteed to eventually get the exact same order twice. The universe is kind of like that, just on a much, much bigger scale. Somewhere out there, there's another Earth, and another you.
According to the math, your closest identical copy is about 10 to the power of 118 meters away. That number is so ridiculously huge, it's basically meaningless. It's so far you can't even imagine it. So yeah, a perfect copy of Hawkins, Indiana might exist out there, but trust me, a Demogorgon is not about to bust through your wall.
All right, our next theory comes from cosmic inflation. The idea is that in the tiniest fraction of a second after the Big Bang, space itself expanded way faster than the speed of light. But here's the thing, it wasn't a smooth, even expansion. Some pockets of space just stopped inflating and cooled down, forming these little bubble universes like the one we live in. Meanwhile, the space between them just kept on stretching.
Someone came up with a great analogy for this from the old arcade game Dig Dug. You know the little pockets the player digs out? Think of those as individual universes. And the dirt between them is the space that's still inflating like crazy, pushing all those universes apart faster than the speed of light. So, once again, even if there's a bubble universe that looks like the Upside Down, it's racing away from us. We could never, ever reach it.
Okay, so far we've been thinking on a huge cosmic scale. But our third theory, from a physicist named Hugh Everett, brings things down to the tiniest level imaginable, the quantum realm. The idea here is that every single time a quantum event has more than one possible outcome, the universe doesn't just pick one. Nope, it splits, creating a whole new branch of reality for every single possibility.
Think back to that scene in Season 3 when 11 and Max are using their powers to spin the bottle. In our universe, we see it land on Billy. But according to the many worlds idea, that's just our branch. In that exact same instant, countless other universes branched off. One where it landed on Mr. Clark, another where it landed on Steve. You get the idea. Every single outcome happens, just in its own separate parallel world.
These worlds are all around us, in the same space, but completely sealed off from each other.
And finally, we get to the most mind-blowing theory of them all, M-theory. This is a contender for the theory of everything that Einstein was searching for. It suggests that everything isn't made of particles, but of tiny vibrating strings. Now the key part is, for the math to actually work, M-theory needs extra spatial dimensions that we just can't see. Our entire universe might just be a giant three-dimensional membrane, or brain, floating around in a higher dimensional space.
You know, Mr. Clark actually gave the perfect explanation for this in the show with the flea and the tightrope. To us, a tightrope just looks like a one-dimensional line. But to a little flea on that rope, there's a whole other dimension of movement. It can crawl around the side, it can go underneath. In the same way, there could be these tiny curled up extra dimensions all around us that we're just way too big to ever notice.
Okay, we've just gone through 4 absolutely incredible, brain-breaking theories. But now we got to get a reality check. How do these ideas really stack up against the upside down? And more importantly, is this actually science? Let's break it down. The infinite universe theory says an upside down could exist, but it's just too far away. Bubble universes could have all sorts of weird physics, but they're speeding away from us. Many worlds are right here, all around us, but they're completely sealed off. And that leaves M-theory. Of all of these ideas, this is the one that gets us the closest to Stranger Things. Another brain, another universe, could be millimeters away from our own, close enough that you might be able to interact with it. Or maybe, just maybe, punch a hole into it with a whole lot of energy.
But, and this is a really big but, we have to bring ourselves back down to Earth. This is all theoretical. None of these multiverse theories have ever been proven, or even successfully tested. In fact, some scientists will tell you they can't be tested, which they argue means it's not even science. So for now, it's a really cool thought experiment about just how strange and vast the cosmos could be.
So the multiverse is out of reach. Or is it? Remember how I said that in the many worlds theory, the universes are totally sealed off? Well, there's a new, mind-bending idea that suggests we might already be knocking on their door, using our own technology.
Okay, this is a pretty radical idea, but stick with me. Some physicists think that quantum computers get their impossible processing speeds by cheating. They think these computers are essentially outsourcing the work. When a quantum bit is in multiple states at once, it might actually be running calculations across millions of parallel universes at the exact same time. Now, if they're right, the multiverse isn't just an abstract theory anymore. It's a resource we're just starting to tap into. So forget portals and demogorgons. The first visitor from a parallel world might just be the answer to a really complex math problem.